All right, let's begin. Welcome and thank you back to the stream on Twitch. To our YouTube viewers, welcome back to our video series where we are hoping nothing else goes wrong and trying to push this stepper driver project forward. So in the last video and stream, we got past and started plugging and chugging some more firmware on the system, and we're going to see if we can get the stepper motor to start driving and get the the limit switches operating, reading properly, because we already got them reading properly, but we need to start getting the logic put in place, so now we could get the stepper motor driver to get the gantry running and start coding in some of the other sub functions and subsystems that we're going to need for this. So let's go over to the main screen, I should say, where we've got VS Code open. So without further ado, let's go ahead and jump in it and start. All right. My keyboard, I think, must be going bad. DRV 8825. So what we're going to do is I'm just copying and pasting, and then we'll just clean it up. Let's see here. Driver. Wires. GPIO. I think that's what we need. No, I think no, I think that's fine. I think it's fine. So we're going to rename that DRV 8825.c. .h. All right, there we go. All right, so let's go to the header and get it cleaned up. All right. Header file for the DRV 8825 stepper, whatever I see. All right, we'll clean that up when we don't need it. All right, there's that. Save that. Come over here. A little bit of time. All right, so we go. GPIO 8. Okay. See, okay, we will clear all this up. We will clean everything up as we go. So in the header file, might need that stuff. That's fine. We don't need the UART drivers. All right. fine. We do need the GPIO. No, I don't think we need that there. We need that here. All right. So we need to figure out the basically the pins we're going to need. GPIOs that we need to make sure we have defined. And I seem to have misplaced my little notepad. So we're just going to go ahead and pull up the KiCatch schematic. Pull that up real quick. All right. Step driver. So what we're going to do then is basically create all of our GPIOs based off of that. I'm going to drag that off the screen. That way it's not in the way. One at a time, we're going to get this going here. Step enable for see. So what we need to do is we're going to see step enable. Active high. All right. We have to make sure we qualify that. All right. All right. Reset for the see flow. I'm going to double check that. I think it is. Yeah, I think that's active low. Yeah. Okay. Now we're going to need direction control pin. All right. Now, I know there's a step pin, but we're not going to worry about that this minute because it's it just needs to be an ET. So direction. No, it could be. No, it can be fine. All right, we don't need these guys. Clean all of this up here. Yeah, we're going to clean all this stuff up because we're going to be using, for this, the same interface will just be using LEDC, basically just a PWM interface because the speed was fine to drive the gantry back and forth. We don't need anything fancy for this. Who knows, we may code in something that we can better control the steps. But we'll work on that as we go. Right now, this is just to get things going and up and running and to start, that way we can start actually getting this guy put together. So let's get, we have a separate step. All right. We also have underscore. Let's see. I don't know. All right. Then we're going to need the generic fault condition. All right, so we have the enable, the reset, the direction, the actual step, microstep 012 fault. All right, so that should be all we need for that fella. So let's go and we need to throw in the lead C stuff. All right, so include the lead C. Include. All right. Well, I don't think we need that here in this guy. No, we don't. Need that over here. Like I said, all right, so there's that. We don't need this. So, let's kind of think about how we want this to kind of flow. So we can figure out our prototypes. We'll kind of start getting some of it defined over here. So this is the C. All right. So so we don't need a lot of this junk here. Let's clean that up. Let's get rid of all right. It's nothing to, well, yeah, we do have to init. We have to initialize the oh. All right. So what we're going to need to do is we need to come up with an init file. All right. So basically, because we need to initialize the LEDC driver for this. and we might need to know other things. And then we also need to enable all the GPIOs, but all right, what do we need to init? All right. All right. All right. We don't need this garbage. Okay, we, like I said, we do need to initialize the GPIOs. So, come up here. And GPIO pins. Okay. GPIO, let's see here. Let's see here. See here. So from the ESP32, those are all outputs. Except for the fault, which is an input. GPIO. Output pins. CPU reset. And we're not, since we're using LEDC, we're not going to define anything with that right here because I don't think you can. So, MS0, 1, 2. Those are outputs. And then that is STP fault. All right. So like with before, we're going to run through the iteration loop on the input. So let's get some of this junk out of here. Let's get some of this crap out of here. All right. All right. All right. So we have the init. So we're going to perform our GPIO enabling magic. Zero. All right. Actually, right here. Actually, I can just copy and paste from here. Okay. Input. Pins. Okay. Let's see here. IO. Okay. GPIO input. Okay, so the output. We need to set our defaults. All right, so enable. We may have to fix these, but 1, 0. Reset should be 1. Direction 0. Micro step, I think, is 1, 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. GPIO output pins. Okay. Crazy. Let's see. Mm-mm. Oh. All right, so that should work. So let's see here. Bum, 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 bum. Blue, 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 pink, red. Okay, something. Should do it right there. All right. All right. Need to send. Get rid of this guy. All right. Argument. DRV 8825. Task. Don't know what we're going to put in this task yet. Not sure yet. Oh, if we want a task. Actually, yeah. I think this is the task where the actual stepper and everything will be we'll handle all the controls. Okay. So we have the task. So we also need to configure the LEDC driver. So let's see. So we're also going to need to know let's see. Okay. Um DRV 8825. That way we don't get any of that. Initialize the parameters. Nothing yet. No tasks yet. There we go. It doesn't complain about anything. There we are. All right. So we have that. All right. So here's a C. It comes here. Now we need to figure those. So we need to. All right. Figure. All right. Timer. I need to make sure. Okay. What is that? Step. All right. And we've got, what's the STP duty? All right. So we will set a default duty cycle from the main loop, which should normally be 0, but for our purposes, we will, for testing purposes, we will. All right, so set up, all right. / all right. System. Now, I'm just copying and pasting these. So we have here. I don't think we actually have to declare it as declare the type, because we already did it. I think that's just a waste of time. It's just habits do that to me. Um, 0. No. Let's go. What's cool is I kind of already have them enable for reset 13 direction 5. There's the staff. It's 12. That is 0, 15. 17. All right. Step of fault. And that is... All right, ESP32. Step of fault is 18. Now, even though that's going to default to 0, but I want to... and we should... This should work. We'll get that going. The 45 console. Don't really need to care about the inputs right this minute. So we need to initialize the stepper driver. Okay. And it's a default zero. Typically 0. All right. We're not really caring about the GPI, the inputs yet. I mean, we don't. Because what's going to happen is I'm going to code and kind of forgot that I set that to 0, so it's fine. Okay, so we have that going, that going, that going. All right, let's see how much she bitches at us. All right. Oh, okay. All right. So we do have to declare. Oh, weird. Oh. So I also kind of forgot something here. No, I don't think I forgot anything. No, it's not 0 to 100. Yeah, no, it should be 0 to 100. I will figure it out. We will figure it out together. Okay, so it's mad at me. Let's see here. Huh. Mm. 21. All right. All right. What are you mad at? Wait a minute. Okay. 41. this. Previous declaration. $42. Okay. 42. Okay. What am I doing wrong? What are you mad at? Okay, that's fine. That worked. Why are you mad at me here? Oh, that's fine. Okay. Yeah. Why are you upset with me? Because it's literally no different than any of these other guys. Literally no different. Extra unit. Oh. Why are you upset with me? Let's try cleaning that. Let's rebuild it. Maybe I could get a clear understanding of what's going on with this because I have no. Okay, I've got all the. You went. Huh. In the world are you mad at? Hmm. Understand what you're mad at because it's not that much different than I'd be more understanding if it was the LEDC driver upset me, but mad because of why are you mad? That's fine. Those are fine. Defined but not used. Defined but not used. It's not initializer element is not constant. Oh. What? I see why. I wonder if I can change that. Oh, it looks like it can. So let's. All right. See what that does. Oh, come on. Stop. I don't care if it's undefined. Okay. Why are you mad at the task? Next task create. Yes. Why are you upset at that? Oh, wait a minute here. Oh, that's why. Okay. We need to configure our prototypes. Oh, are you kidding me? Stop. Stop. .5.c. Why are you so mad at me? Why are you such a hateful thing? Let's see here. All right. Let's strip that. See if that goes away. Okay. This one too. Am I? No. Why? 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 Not constant. Does that mean I can't do it that way? Iterate through that dang loop? We may have to put together a struct or something. I don't know. This thing just does not want to work. Why? All right. Is not constant, but it is a constant. I don't understand. It's even declared here as constant. What in the world? Why in the world are you doing this to me? I mean, I guess what we can do is, since this is for this, do we really need right there? That should satisfy that. Because realistically, for this dev kit, those aren't going to change. So we go over here. We don't really need to declare them as variables because they're pushed in here. I mean, technically for this dev kit, they're not going to change. All right. All right. Let's see if we can shove this guy over and see what happens. The motor should. All right. So it did push it over, but the stepper motor's not doing anything. So we come here, we init. No. Didn't complain about any of that. Oh. Again. Okay. Based off of this, that motor should be doing something. Should init. Let's get rid of that. Yeah, I know there's a unused function. You should be spitting that driver mode. That stepper should be driving. Okay. All right. Oh, you know what? Maybe. Right. I mean, it should just go regardless, but let's see what happens. Oh, come on. Okay, so why aren't you doing anything? Do I have the wrong stepper? Step IO12. Okay, no. 15, 16, 17 for that. Oh, huh. I bet you it's our default. So stepper enable. I did this to myself last time too. Okay, okay. Enable. Reset. Okay, that's what I did. Because by default, we want it disabled, so it's not going to do anything right off the bat. Okay, that should fix it. I hope. Yeah. I have to figure out why it's doing that weird skip, but let's go over to doing something weird, but we'll figure it out. It's all coding. So we got the motor, spinny. Part of the vibration noise is the it's not tightened. Let's see if we can adjust some of it here. All right. Okay. Oh, active high. Low. For driver to work. Operate. So that might be doing it, might be resetting the let's see what that does. All right, we're gonna flash that over. Might play around with the duty cycle and stuff to kind of slow it down if possible. Nope, wasn't that doing it, so all right, so let us drop the duty cycle down. See if we can get rid of that. Also make sure it's got to be wired in right. I have to adjust the frequency. We might be able to set those as variables that we can push over. We'll see. Do we even have this poor thing wired up right? Let me see. Because if okay. All right, color code images. I don't really care about that. Just show me the color. All right. Nope, I don't like that one. That one's not showing me very well. All right. Because I don't like that weird skipping that thing's doing. Okay, so we've got. Okay, B minus is blue. No, it should be right. You know, those ones. Why in the world has it got that weird skipping? Right. Why are you doing that weird skip thing. Could be the micro-stepping. Could be the frequency. Could be any and everything. We may not. It may have been doing that from the get-go. All right. Let's try this. Drop the frequency a little bit. No, I don't know where that skipping's coming from. That's going to take forever to fix. Now we got to play with the micro-stepping. Yep, and this is why I wish the that UART chip didn't break, because then I wouldn't have to keep hitting those buttons to upload. It would just use the USB and automatically reset the device for me. Okay, that's as annoying as that sounds. Let's drop the frequency. Let's drop the frequency. We don't need it super fast anyway. Oh, that's so annoying. All right, let's change the micro-stepping. So it's going to be 0. Step enable, reset directions. So build it. Right. Okay, let's reset. Oh, you are getting so annoying. So annoying. I don't know why it's skipping like that. That is so annoying. It's skipping. Why is it? Why is it skipping like that? What the hell are you doing? It's like it's like it's resetting and like stopping every so often. All right. Stop the frequency a little bit more, which is probably going to make it mad. Yeah, again, this is all a dance of the PWM frequency and the duty cycle. I don't know why it's like I hope it's not the motor. I hope it's not like it's got a dead spot inside or something. So 5,000 hertz seems to be okay. The only thing we could do real quick is, do I have another motor readily available that I can hook up to this guy? I've got the one. Let's see if I can find that guy with the really short leads. Because one of the things it could be, you're not in here. All right. What do I do with you, you little fella? What I'm afraid it is could be a motor that's having an issue. Do I have any of these little guys laying around? No, I don't. So, grab my bin. And see if I might find my little friend Stubby that little Stubby guy. I don't know where I put it. Sorry for the loud clicking. I didn't mean to explode that in your ears. Huh. Don't know where the one little motor went that I have. The other little guy that had the really short leads on it. I would like to hook that up real quick. But I set it aside and I don't know where I set it aside at. Because it's not the back in the bin where they're supposed to be. And my phone is doing something dumb again. Will you stop doing this, you stupid phone? Oh my. I don't know why my phone wants to keep doing this. Yeah, Gemini is coming off. Yeah, Gemini's coming off this phone. Yeah, I have no idea why that stepper motor's doing that one. It's like skipping. Could be a bad motor. I mean, these poor things have been abused and beaten up and pushed around in this system. They really have been. So it would not be surprising at all that this motor's got some issues and we just didn't notice it. But you know what? That's a problem I will solve off camera. Because the motor does work. So one of the things we want to do, we do have it running. We don't need that to be constant. All right, let's clean this up. All right. Make sure I'm pulling that one right. Turn. Because we will need to be able to change that from the outside. Oh, we need to build it. Oh, I don't know how we fix this. I don't know how we fix this. We're going to have to fix this in such a way because we're going to need access to change the motor direction and all the other stuff. So the fancy little initialization routine may not work. Oh, no. What? Oh, I might have to figure that out, solve that problem. Because I definitely want the stepper motor driver to be an external module. That way it makes it easier to drop it in other applications. I mean, if we have to go the long way and initialize each pin one at a time, I mean, there's not like a ton of them. We can get rid of this routine. That way we don't have to worry about the iteration loop and just initialize them one at a time. All right, so we don't need, let's see here, STP duty. What is that, 20? We don't need it here. Right. So that should build, or you've, what? Oh. I don't know if I actually spell it right. Oh. Just shoot me now. Just shoot me now. Now. We should be able to flash it. Oh, we should be able to flash it. Oh, nope. Go. Uploading. All right. Yeah, I don't know why it's pausing. Why it's doing it. Weird. Weird. Let's try to slow it down a little bit more. Because then maybe I can see something cyclical by watching that mark on there to see if it happens in the exact same spot. See, slow it down, drop the duty cycle. in the world are you doing that, you goofy little motor? If we have a really low duty cycle. See, because this is my understanding, the way this is supposed to work, the duty cycle is supposed to help control the speed, and it's not. So we might have to actually write an actual driver. Yeah, the speeds maintain the same. It's like, then what's the whole point of the duty cycle? So I got to figure out why the motor's doing that weird little chunk thing. And then I've got to figure out how to set it up, because we're going to definitely need to because the enable, the reset, and the direction, well, all those pins we're going to need to be able to modify externally. Oh no. Ugh. Yeah, so we'll have to worry about fixing that, because we need the main program to be able to go in and say, hey, we need to disable you, we need to enable you, we can't, yeah. And we could probably send commands to the driver, like switch direction. No, we could actually tell it to switch direction. Because right now, let's see here, step direction of 0 is counterclockwise. So we could tell it change direction and change direction clockwise, change direction counterclockwise, and it can handle these pins. So no, I think we might be okay. It's just the commands. We're just going to send commands and then let this driver handle what it needs to do, like set, MS0, blah, 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 high or low or whatever. So I think we can still work with it, read the fault. No, I think we can do it. So I'm going to try working off camera, see why that motor's acting up. See if it's the motor or if there's just something weird, anomalous with this driver that's causing it to do that weird skipping, and why I can't control the speed. And hopefully in tomorrow's stream in the evening, we'll have a solution for that. So I want to thank you for hanging out with me this afternoon, and I really appreciate it, but we've made some progress. And we'll see where we can go tomorrow. So thanks, and have a good rest of your afternoon.